thank everyone for attending. And obviously, take a moment to thank Andy for putting it together. I said before, 90% of it is him, and then the rest of it is Kelly putting all the marketing stuff together. So all the views in it are his. So if you don't agree with him, just tell him. But other than that, we're going to be recording. So he's got a YouTube channel that he's putting a lot of the content on, and the name of which is his background, and it's on the last slide anyway. And if anyone has any questions, just feel free to put them in the little chat section, and we'll just go through them at the end and just riff off as many as we can, basically. So I'll stop waffling on and hand the reins over to Andy.
Right. Well, I'll just sort my screen share everything out. Bear with. Right, you should be able to see a whole picture of me.
We can do.
Okay. Let's just get my. Okay, well, introduction of who I am. Some of the people on this probably do know me because they've worked with me, and I can only apologise for them having to do that. I currently work at Lookers as a software development manager. Prior to that, I was at a company called Fast Track Automotive for nigh on 11 years as a software developer and sort of lead developer. I have a very small YouTube channel thing, which I started before lockdown. Irony was that as soon as lockdown hit, I didn't have time to do anything with it, which is why there's not a lot of content on there. Ethos behind that is I'm trying to start to impart things that are in my head, or things that have been in my head for a long time, in a way that other people consume it at their own pace. I have found that I struggle to communicate things in person, and I get very irate if I have to repeat myself. So it's on the basis that put it on a video, somebody can watch it over and over again, and comment on it, and I get a chance to sort of edit out the bits where I get it wrong or do say the wrong thing. So by all means, have a look. It's not that exciting. Today's sort of talk thing is entitled From Legacy to Legacy with test-driven development. I kind of came up with a title before I came up with the content, so it might not quite flow as people might expect, but we'll just see how we go. The bits we're going to cover are how tests relate to legacy code. So that's kind of looking at how certain code bases get in a mess, how they end up where they are. What, in my opinion, legacy code is, which could be controversial to some people. Quite a lot of people see legacy code as just technology stack or the language it was done in. So a little bit about what the difference is and what you get doing test last versus test first. How test-driven development creates a kind of new kind of legacy, and how that test-driven development approach, in my opinion, fits into the core of agile development. Excuse me. So, in the beginning, I'm going to consider a world without tests. So this is the apocalyptic world where there's absolutely no unit testing at all in your code base. And that can be really fast, really fast in the beginning. So in greenfield projects, stuff gets done really quickly, features get written really quickly, and that's great. So there's an initial flow. What tends to happen then is the complexity of that code increases as it take on more devs and more people have a hand in it, or you have to change it more. It just becomes harder and harder to make changes to that code. And then you find you sort of turnover of staff, increased teams, more and more people working on the code. The understanding of that code starts to decrease. So you end up with some people pointing across the office at somebody who said, well, he wrote that, go and talk to him. And eventually you get this sort of fear of change starts to take hold, where nobody will actually change any code. So it just starts to sit there and rot and be left, and nobody's going to touch it. And at that point, eventually, basically, your code's become rigid. It's not willing to change, and nobody's willing to change it. So at that point, if it wasn't considered legacy code before, which we'll come into in a minute, it kind of really is now. And that comes out with a world without tests basically gives birth to legacy code. So it's one of the ways that testing is linked to this concept of legacy code. So I've mentioned legacy code now. So what is it? This is my opinion. So some people might disagree with me, some people might agree, some people might be roughly on the same page. So taking some opinions that are out there from other people, there's a guy called Michael Feathers. Some of you may not have heard of him. He's written a really good book called Working Effectively with Legacy Code, which basically takes you through methods and approaches for transitioning legacy code bases. And in his terms, that's code bases that don't have tests or they're not under test at all. So there's no unit testing around that code. Transitioning that into code that is testable and under test. Another guy, I'm not sure how to pronounce his name, but Eli Lopan or Lopan. He's the CEO of a company called TypeMock, which is basically a framework for writing mock objects in some development languages. His opinion on legacy code is that it's code that developers are afraid to change. So people are actually afraid to change it. It may or may not have tests around it, in his opinion, but people are afraid to change it because that confidence isn't there. And to answer the question that absolutely nobody is likely to have asked, Michael Feathers is actually not a Russian handler in Killing Eve. That's a guy called Konstantin Vasiliev, and as far as I'm aware, he has absolutely no opinions on legacy code. So combining those two definitions, this comes down to my kind of opinion of legacy code. So code that's covered by comprehensive and granular tests that assert expected behavior for all anticipated and discovered usage. What I mean by that is you've done the happy path stuff and you've done the degenerate path, so that you've defined how the code is intended to behave when it's called wrongly as well as rightly. And also code that's decoupled and can be refactored and how its architecture changed without fear of introducing anything unexpected. So that's basically a definition of clean code. And what I'm basically saying is that anything else is legacy code. So code that's not under test, it isn't easy to change. You can't change without fear of introducing more bugs than you sort of getting rid of, so on. So one of the things that people need to do, or I think people should do, is if they've got legacy code, is introduce some form of testing. This is what Michael Feathers' book sort of goes into detail with. But adding tests, you've got to consider that just the existence of tests isn't really enough. Those tests actually have to be valuable. So they have to assert and provide what the expected behavior of the code actually is. So just having a test that runs the code but doesn't actually assert that the outcome should be this, or the outcome should be that, or it should do this, or that should have happened. Without that, the tests are pretty much useless. And you do find, or I have found, quite a lot of code where it's had tests put around it, but they're almost meaningless. They should never, ever be written just to increase code coverage. It's the most dangerous thing that anybody could ever push a developer to do, is to measure them on code coverage. As soon as you do that, it means you're writing tests just to prove that it runs all the lines of code, not that it proves behavior. You can get 100% code coverage on almost any code base by writing tests that literally assert nothing. So right back to the top, by writing tests that aren't valuable, you can get 100% code coverage, but it doesn't prove anything and it doesn't help you. So that fear of change can only really and truly be removed by having well-written and granular tests. By granular, I mean tests that are testing more than just the big picture end-to-end scenarios. So you start tests that are actually testing the inner workings at a really granular level. So just a little bit about sort of where it goes wrong and why we end up with code that's in this state. So considering code with no tests. So there's quite a lot of excuses. Originally, I had reasons on the slide, but I don't think a lot of my reasons are genuinely excuses. So opinion that testing is somebody else does. So there's a test function within the development team, there's a QA department, and there's an attitude that it's that department's job to test the code. So there's no need for any other sort of testing to occur. We just do testing for the UI. So there's just developers are doing testing, but they're doing it by running the code, operating it manually for the UI. The problem with that approach is that if you're finding a bug or whatever, you fixed a bug, you'll do a test for the UI to assert that that bug has been fixed, which is fine. That's fixed the bug for them. So when you come to fix the next bug, you have to remember to do exactly the same test that you did for the first bug you fixed to prove that you've not reintroduced that one, and so on. So the amount of testing you'd have to do every time you changed anything would be immense. And that's where costs start to go up. The attitude that we just know the code works. We've written the code, we've tested it, it works. So there's no need to put any unit tests in. There's also a greenfield mentality. So, when you start off, it's fast. We don't need tests. We know where we're going. It's all well designed. It's well architectured. It's all good. The risks that kind of come out of that are you end up with complexity, the fear of change, high cost of change. So as it gets harder and harder to change code because there's no confidence in it, or it's complicated, or it's kind of all got muddled in together and people are just sort of tagging bits on the end here, there, you start getting code appearing in the wrong place. So you end up with sort of business logic stuff shoved in a UI and business logic stuff stuffed in stored procedures in the database, and end up with display HTML shoved in databases, and things just get in a complete mess, and it's really hard to change it. So it means that making any sort of change is at high cost. It then got sort of code rigidity, which falls on from that. High QA costs. So if you've abdicated all the testing to this QA function, every time that code changes, there's a sort of a large quantity of people doing a whole host of testing, which can run into hundreds of pages of tests and things for large applications, which means that the cost of testing can run into thousands, in some cases millions, if you've got really big code bases where unit tests basically cost nothing. You also end up with the you changed it, you own it, blame culture. So no developer wants to touch a piece of code because as soon as they touch it, they become the owner of it, and then they'll get hassled if it goes wrong. That eventually leads to low developer morale and can lead to high staff turnover, which again then feeds into the top of this argument that if you've got high staff turnover, the knowledge about the code base is starting to reduce. People are struggling to understand it, struggling to change it, and you just go into almost a death spiral. The other side of that is code where you've got some tests, but they're not of a particularly good quality, or they don't cover all the code. So the excuses for that usually are we only write tests because, or if we have time to get good code coverage, and as I mentioned before, that's the worst thing you could ever write tests for, because somebody has told us we have to. So I've heard people say that they've got project managers that tell them to do test-driven development, or project managers that tell them they have to write unit tests. Some other arguments are that they're concentrating on sort of architecture and implementation first. So we're doing a lot of upfront design, and because we've done that, we don't need testing because we've written it to the specification, therefore it all works. Risks, again, of doing that is you get a little bit more time spent doing debugging. You tend to get less regression integrity. So you've got tests, but do they actually give you any value? Do they actually help with the knowing the code works? You often get undetected merge issues, because there's a mentality, we've got some tests, therefore they'll detect things that go wrong. And that's where if there's less diligence over merges of code, you get stuff that compiles but doesn't behave properly. If that behavior is not covered by a test, then you're going to run into a problem. So that could leak into a production environment. These are all usually things that are driven or caused by a top-down influence on development. So it's imposed testing, as opposed to professional developers taking ownership of their own code and the ownership that it's functional and works properly. And that's what I refer to as a sort of a test last legacy, if you like. So just to pick up that term, when you have some tests that cover some of the code, that means when you get a failure, so a failing test when you build, or a failing unit test in your IDE, that tells you that something's broken. So there's something you can go and fix. So there's a test that's proven that something isn't quite working how it's supposed to go, and that's good. The flip side of that, if all the tests pass in that scenario, so not all the code is well asserted that its behavior is not fully covered by all the tests. So there are some paths that aren't covered. There are some outcomes, degenerate behaviors that aren't covered. That means that when all the tests that are there are passing, it tells you actually nothing. And that is like having a red traffic light. So you've got a red traffic light, but only the red bulb works. So that red light comes on, tells you you've got broken tests on your build. That's great. When that light goes off, what does that mean? Does it mean the bulb's gone? Does it mean that we're in a go state? Or should we just proceed with extreme caution? And I think it's the latter. You've got something that tells you that something's broken. And if nothing's broken, then just proceed with extreme caution because something else might be. So the ethos really is to keep it tested and keep it clean. So if you intend to keep your code in a state of under test at all times, so you want code that is 100% tested, so that when you get failing tests, that means something, and when you get your test passing, it means that your code actually works. So if you're looking to do that, why would you write, by my opinion and definition, legacy code first, i.e. code that's not under any sort of unit test, and then transition it into testable clean code? So you're writing legacy code and then transitioning it all the time. The only way, in my opinion, that you can truly have code under 100% testable all the time is write tests first. And there's an easy way to remember write tests first, because it's very similar to another phrase. So legacy code transition. The first bit of advice is, if you haven't got a copy of it, buy a copy of Working Effectively with Legacy Code. It's a really useful book, not just for people who are looking to transition, for understanding or as an introduction to some forms of unit testing patterns, ideas about decoupling code and transitioning architecture. It's a really good book. So the first steps to that sort of transition process, so this is where you've got, by my definition, a legacy code base that you want to move towards having eventually a full test suite around it. So the first step is to do the 50p, 20p refactoring. If you don't know what 50p, 20p means, then Google it. But effectively, that's the risky bit you've got to do up front. So that's finding some edges in the code where you can decouple it and start to have an entry point for a test and find an exit point for a test. And the reason it's a risky thing is because it has to be done without any tests. So there's nothing that proves that you have or haven't broken it at this point. That allows you to get a characterization test around that element of the code. And that is just it's a reverse engineered test. It's a test that's, you're taking a known input and then you're taking the output that the code actually generates and putting that into the result of the test. So it takes the piece of code and proves that it works how you think it should do. That all works on the assumption that the code is at least reasonably working. After that, it's kind of an infinite loop of refactor, decouple, test, and repeat. And by that, I mean, you're going to refactor, decouple the code. So you're going to do, now you've got one test around it, you do a bit more refactoring to find some more edges where you can find entry points and exit points at a lower level. So you're going down into the code and trying to get to the point where you're testing the most innermost sanctum of that code base to prove that it works. So once you've got those new surfaces, you introduce more testable, so you've got more testable surface area, if you like. You can then add more granular tests to the code. That creates tests that are asserting behavior at a lower and lower level as you go down. So try and triangulate your tests. So don't just write one test around stuff. Try and run the code from a few different angles, and that should include your happy path stuff, so how it's supposed to be used, and to some degree, what happens when you pass variables in that are wrong. Try passing nulls in. Try passing things that aren't complete, and you can assert what the behavior should be. At this point, it can start to move from refactoring into changing behavior of code, as you might actually find some behaviors in that code that are wrong. But as long as the tests are kind of written and you're proving what it should do as you go down, you should be fairly safe. Obviously, as you go down the code, all the tests that are higher up should still pass. If they don't pass because you've changed something fundamental about the functionality, you have to be very careful about whether you should change code or test. So moving forward, the really, really important thing is don't make any more mess. So don't take something that's not quite working and make it any worse. So when you're adding new functions and new code, you need to do that in the right way. The other thing about it is that you can't win the war, you can't get to the end of this if you don't live to fight another day. So it's really important that you don't try and do the whole thing all at once. I found when I've done this, it turns into kind of trench warfare as you slowly move sort of the line of legacy versus non-legacy code forward. So you don't take the whole application, you just take a chunk of it, you do that, and you slowly move on. Now, this is one of my own, another way of looking at test-driven development, or you can say that tests deserve deference. So those tests do deserve respect, they deserve to be looked after. They are genuinely one of the most important bits, because you can take a set, if you've got a granular set of tests, you can recreate the application for those tests. It's very rare that you can do that the other way around. So it's very rare that you're going to take a code base and get it back to a granular set of tests that you would get out of doing test-driven development, which we'll touch on how that works in a couple of slides on. But how this works for going forwards is you treat a bug literally as a test you missed. So you get a bug in the system, the first thing you should do is try and get into a position where you've got a unit test that proves the code path that is causing that bug. So you've got the inputs that cause the bug, code path through, and then you put in what your expected behavior should be, i.e. what the real result of that execution should be, as opposed to the execution that's happening now where it's going wrong. That means that you've got a test first, and then you just fix the code to make that test pass. So that's how you fix the bug. The very next thing you need to do is make sure you run all the other tests and make sure all those still run, and make sure you've not broken anything in the process. Then consider adding tests for any similar scenarios. So don't have that blinkered mentality of this one thing for this one bug, this one scenario did this. Think about whether there's any other scenarios that are very similar, any other path that's close to the one that you fixed the bug on that it could be failing on. And then triangulate those. So try it with a few other, so test the same piece of code with a varied set of inputs and assert that all those come out with the right thing. And then whenever you're writing new code, write tests first. So follow the laws of test-driven development where it's possible to do that. The reason I had that caveat of where it's possible to do that, there are some elements that, there are genuinely some bits of code that are hard to do test-driven development, but I'm not going to go into any depth on what those are and why they occur, because it will take me ranting for hours. Don't go too big too soon. So the big upfront test issue, so it's like test-driven development waterfall approach. So don't try and write a test that almost asserts the entire behavior of the whole application all in one go, which I've seen people try and do. So they try and assert the entire outputs of what is going to be a very long code path in one test up front. Go really small, and it tends to help to go degenerate first. So it's easier doing test-driven development to assert the things that should go wrong first. So asserting what happens when you pass all nulls in first, asserting what exceptions you should get back on doing the wrong thing. It tends to be easier to start at that level than it is to start at exactly what it should do straight off the bat. So you move from the outside in. So you go from specific to general behavior. The other thing is try and push humble objects as small as possible. So humble objects, if you don't know, are things that are considered untestable. They tend to be things that sit around either third-party libraries, physical interfaces to hardware where you don't have a simulated version of that hardware. So things like output and comports, things like that. So things that are genuinely really, really difficult or impossible to test in a unit test scenario. Things that's where you get value from things further down the line. So testing strategies such as doing integration tests, doing behavior-driven development. So things that are sort of testing the code in a more closer state to it running in a live environment than it is sort of when you're running sort of unit tests within the IDE. So. And the other important thing is don't test the framework. A number of times I've seen people write tests that pretty much only assert that the framework is capable of doing what the framework said it was capable of doing. That's not useful. It doesn't help anybody. So test-driven development. So the actual act of doing it, test first. The basics are there are 3 laws. I've taken these from Robert C. Martin, or Uncle Bob's view of test-driven development. So the first law is that we're not allowed to write any production code unless it's to make a failing test pass. So that's easy enough. We don't change anything in the production environment unless we're actually doing that to fix the failing test. So in the production code, unless it's to fix the failing test. Then we're not allowed to write any more of a unit test than is sufficient to fail. And compilation is failing. So if you take that from a very simple point of view, first few lines of a test could be var variable equals, and then a function name, open brackets, close brackets. That function doesn't exist. So at that point, it fails to compile. The first thing we're going to write in the production code is that function. So we make that test compile. So if we treat compiling, not compiling as failing and passing, certainly in the initial parts of that. And then we're not allowed to write any more production code than is sufficient to pass the test. Now, this is a bit that a lot of people struggle to get their head around. So just creating the function, it not returning anything is enough to fix that compilation error. It doesn't mean we've written any working code, but it's fixed the compilation error, so we can move on to the next bit of the test, which could be defining what we're passing into the function, which then that won't exist, and then we have to create that, and so on. And this locks you into a very, very, very small loop of moving between test, production code, test, production code, test, production code. And that's in a cycle. So generally that starts with red, which is your failing test mode. So at that point, you've got a failing test that you need to write something to fix. So that's a test that's either doesn't compile or a test that's its assert fails. Green is where you've made that test pass. So literally, you've made the little tick against that test go green by writing as little production code as possible. Once we're in that state, we've got the opportunity to refactor code, so change its structure, make it read better, move it around, change its architecture. And the last bit, which isn't generally spoken about, is that you're clean and commit the code. So at that point, you're in a nice place where all your tests pass and you've done refactoring. So commit it. So you've got a line in the sand that says this bit works, and then move forward. And it's just a repeat of that. So red, green, refactor, clean. So what are the advantages of test-driven development? These again are in my opinion. So I find that it's easier to cope with distractions because we don't live in a perfect world, especially not at the moment. The world is far from perfect. We get distractions, we get phone calls, we get wives, husbands, children, people at the door, Amazon delivery guys who come twice a day for no apparent reason. So those distractions mean that when you're writing code in the traditional zone sense, so you're doing the flow mentality thing, you're writing lines and lines and lines of code all at once, really deep into it, you're focused on what you're doing. At that point, you get distracted. It can take you half an hour, maybe more, to work out exactly where you were, what your thought process was, what you were exactly doing. Doing test-driven development gives you an advantage that you're in one of two states all the time. You're either going to be sat with a failing test, which is telling you what the bit of production code you need to write is, or you've got a set of tests that are written and passing. One of the things I tend to do on the side, and there are a few thoughts on how to do this, and that's either have a pad at the side of your desk where you write, as you think of what the next test should be, write it on the pad. Other people do it as adding to-do statements inside the unit test. So every time I think of, oh, I want to test that next, just put a quick to-do line with something that will remind you what that test needs to be. And that allows you to almost store your state and then resume without too much of a lead time. The big advantage is that because all the code's tested, you tend to have less defects. And I say less defects, you still will get defects. The day that a man writes code with no bugs, I will hand back there. Hell will freeze over. But if you genuinely treat the defects that do exist as basically unit tests that you didn't think about, or they're code paths or scenarios, test cases that weren't thought of, or something that wasn't explicitly part of the requirement, so it's something you didn't realize you explicitly had to deal with when you started to write the code. And that's easy enough to add back in. So you just do what I said before, you write a test that fails because it's asserting has the inputs that are causing the bug, and you just make it pass, make sure all the other tests pass, and you're good. One of the things I found is once you get into it, is you get a gamification of feedback. So you get, because it's a really, really tight loop, you get a satisfaction element to it. And most people that write software for a living, or they do it as a hobby, or they've come through software development, they usually started by writing a piece of code that said hello world, and were fascinated by the fact that they could make it repeat that all over the screen and do things and do loops. And that's the gamification. That's instant feedback. On you do something, you get feedback on it. Test-driven development to some degree gives you that. And a lot of whether you enjoy that side of it is a mentality thing. It absolutely gives you decoupled code because you build testable surface area as you go through the code, and you're doing it from the inside out in most cases. You end up with code that's genuinely decoupled, so you can move it about. Most things will have interfaces because you're having to mock objects out and so on. The other thing you get is you don't get any redundant code. And by that, I mean, it's because all the code's testable and you're only writing enough code to make the test pass. That means you're not writing any code that you thought we might need, but you don't in fact need. So that scenario where you sort of you build loads of things that you don't need because you assumed that we'll probably do it that way because you implement it, and then the actual use case versus implementation means that quite a lot of it wasn't needed, or it's been over-engineered. The main thing you get from this is that you get a very, very granular suite of tests that cover all the behavior, degenerate and happy path, and prove that your code behaves in the way that you intended to. And sometimes you get code that behaves in the way that you intended it to, but that's not the way that somebody else intended it to. But the nice thing is you've got a test. All you've got to do is change the test so that it asserts the behavior that's actually wanted, and then you change the code and make sure it didn't break anything else. So it's that confidence and ability to change code that is the key bit that test-driven gives us by making it easy to refactor and change. So those are the advantages. Downsides. As with anything, there are absolutely a lot of downsides to it. The key one is that it's really, really alien to most people that encounter it. So every developer that I have pretty much ever come across has, whether they're on board with test-driven development or not, find it a really weird way to write code. And it is a really weird way to write code. It goes against everything that we learned, when we first started out about we just write something and make it work, and we play about with it and we get it working. That's great. And we get to that point and then we never touch it again because we might break it. It creates what I really call Boswonk architecture, which is, so just because you're doing test first and your code's decoupled and it's, there's no fat in it, so it's really sort of lean code, doesn't mean it's architectured well. Absolutely does not mean it's architectured well. And it doesn't mean that implementation of the code is necessarily right. All we know is that implementation of the code works. So one of the big advantages you've got, because you've got that suite of tests, you can go and fix the architecture. You can go and change it. And I've often been known to sort of do all the tests first, get a piece of code that's working, and then inline everything. Just bring it all back into one big monolithic pile of goo, and then refactor it again. Because I've got tests that prove that all still functions, it means I can undo the architecture that just came out of doing the development process, and with my sort of solid principles hat on and architecturally how it should be, lay that code back out how it should be. So move things around, put it into different projects, split it out into more classes, do some interface segregation, and in some cases even add some more tests because you realize that you can do a little bit more granular testing like now we've refactored it. The other thing is it doesn't really fit that well, certainly initially. So initially when you start doing it, it definitely doesn't fit with any sort of flow mentality, because you're sort of consciously breaking your flow. So you write a bit of production code and you go back to test, and then write production code and write test and write production code and so on. It breaks that flow. So you never really get into that what's considered the zone with your headphones on, music blaring, just writing lines and lines and lines and lines of code. Some people see that as a bad thing, some people see it as a good thing. But again, it's the flip side to that distraction argument for the benefits. The other thing is it takes quite a while to get this as a habit and a discipline. I mean, even now I wander off and I have to slap myself on the wrist, the elastic band on the arm, because I've refactored too early. I've written a little bit more than I needed to in a bit of production code. But we are human, so we will make mistakes. But it's getting to the point where that's a discipline and it's a habit. And there's a reason why we need discipline and habits, which is what I'll come on to later on. The other thing is that it has to be adopted by choice. So it really is a case of you can lead a horse to water, but you can't make it drink. So you can't force a developer to do test test-driven development, you can't force them to write tests first. If they don't buy into it, or they don't understand why they're doing it or what the benefits are going to be, then it genuinely isn't going to help them, because they're constantly got to be sat there thinking, well, this is stupid, which is what pretty much every single developer who first encounters it thinks. I mean, I did when I was all on board with sort of solid principles and things, but this writing tests first stuff, test-driven development, did seem like it was a kind of a bit weird. So unless you get that buy-in from developers, and that comes from time and trying it and having the motivation to go and learn and to do things better. So they've got to be looking to do things in a professional way. Otherwise, they're just not going to adopt it. So that brings us on to sort of agile and test-driven development. So and this again is my opinion, so don't get too wild if it doesn't fit with your own views. So this is kind of what I think's gone wrong with agile, and how kind of test-driven development fits into that. So what's gone wrong with agile? Quite a lot of you probably think nothing's gone wrong with agile. Agile's great, and for a lot of people it is. But you do come across from time to time something that I call projectized agile, which is more so a child of Scrum than anything else. So you get development teams that are banding around the term agile, and you've got businesses that are banding around the term agile, saying we're doing things in an agile way, we're developing in an agile way. And in a lot of cases, it just means that they're doing projects using Scrum or Lean or Kanban or some other agile methodology, which is great. That's kind of the right thing they should be doing. But it often means that there's a project manager-led elements of agile. So the practices, the transparency, the meetings, and so on are being done. So they're being adhered to. And again, this is more so with Scrum than quite a few of the other agile methodologies. But there's no low-level discipline. So there's nothing dictating how the developers should write code. So what you get in this scenario is you get agile with no sort of code discipline. It means we can kind of really quickly and transparently, because agile does give you transparency. So it shows you, we're slowing down or we're speeding up, we've got what velocity is and what flow. So we do all that transparency, but we can then just catastrophically just make a mess and fail. Because if we're not doing that low-level discipline, we are just running down a cul-de-sac towards legacy code. We're going to, start taking longer to make changes to code. We're going to start increasing estimates of code. So you can get a scenario where it looks like the flow in agile is going up because we're measuring velocity on a point, but all that's happening is we're allocating more and more and more and more points to a ticket because it takes longer and longer and longer to do a thing. So we're getting less done, but doing more points. So it looks like from part of the KPIs and MI of agile that we're increasing velocity infinitely. But what we're actually doing is doing less and less and less and less actual change, and it's taking longer and longer to do things. And that's the point when people start, saying, well, do you need more developers, and start throwing more stuff at it, which doesn't necessarily make the problem any better. And the reason that comes about, if you look at the definition of agile, so the dictionary definition of agile is able to move quickly and easily. So agile from the methodologies side of things definitely give you the quickly. So it's a way of moving quickly and changing direction quickly, but it misses that easily part, and that's where the test-driven development and that behavior and discipline come into play. So using agile terms, so velocity, so moving quickly and easily. So just to think about that. So to do that, we're going to need code that's really easy to change. Okay. So how do we get code that's really easy to change? Well, we need code that, it's decoupled and we can easily refactor it without any fear. So taking that fear bit, so the key bit of that, how do we get rid of that? So we need code that's, covered by a comprehensive suite of automated tests. So there's something that asserts the behavior of that code. So we can change it without fear, which means we can do changes easily. So to do that, we need to have a way of ensuring that code is testable and decoupled. And that's what test-driven development technically gives us. Now, there's a lot of people that don't agree that test-driven development is the way forward and the maximum value, and there generally might be another way of doing it. There might be another discipline that I'm not aware of, there might be something else, but I just don't know what that is at this point in time. What I try to do is learn as much as I can from as many people as I can. So at some point, if something else rears its head, then maybe that'll be a better thing. But at the moment, the only thing that gives us this, in my opinion, is test-driven development. And that comes out of, so I've been banging on about disciplines. So disciplines, if you consider those disciplines to be professional habits, so looking at other professionals, so other real world things. If you take accountants, for instance, they have double entry bookkeeping, which is kind of very similar to test-driven development. So you're adding and taking away from two columns and making sure that there's no errors in your calculation at a line by line measure. You don't get to the bottom of the sheet and then find your £200 out and then try and work back to find out where that £200 came in, and then change it and then see if that works out all the way down or it's not. So going back up and down that list of figures to try and work out whether it was one mistake you made, two or three. Double entry bookkeeping gives exactly the same as test-driven development. So it gives it a granular level of test that gives very, very quick feedback as to whether anything went wrong. So in surgical, they wash their hands. That's a pretty simple discipline that we all agree with. And believe it or not, that was only about 130 years ago or something that they decided to start doing that. And I would imagine then cleaning their hands was probably as alien and weird as test-driven development is to you now. Pilots in aviation use verbal callouts. They have a set vocabulary that allows them to go through checklists in the right order, identify deviations from checklists or deviation from procedure so that they know who's flying the plane when there's a co-pilot. So if anything gets into trouble, they know what's happening. If you want to see a really good example of that in action, watch the film Scully. Because when that plane starts to come down into the Hudson River, you see that aviation pilot call out, calm, collected, take control of the plane, and they get it landed and everybody gets off safely. If they floundered about, did anything else, didn't speak the same language, that plane would have ended up killing a lot of people. So software development, as I said, test-driven development is certainly a discipline that gives us a level of comfort in the same way that those other stuff do. So coming back to sort of Agile and where that sits. So in Agile, we're looking to create value and we want to do it at velocity. And absolutely, we want to do that with Agile principles across the board. And we want Agile values. So we have some Agile methodology, and that's fine. So Scrum, XP. That's XP in extreme development, not XP as in the operating system. XP is probably one of the ones that a lot of people don't know a lot about. It's the one that I tend to follow, derived by Kent Beck, who's basically the forefather of test-driven development. So XP is one of the few that does already have test-driven development as a core of its discipline. Probably what I do at the moment is probably extreme Scrum ban with a bit of waterfall. Just being realistic that most people that do Agile do their own version of it. It's never really by the book. And at the core of that, you've got test-driven development, which is absolutely a discipline that helps you keep all those values and principles in place. It lets you move quickly, change direction quickly, because you're not afraid to change the code. You're not a change, doesn't matter what that change is, there's no fear in doing it. That comes to create a code legacy. So leave code behind that you're proud of, that you'd be happy for somebody else to look at, somebody else to, knowing that they'll understand what it is. Don't leave legacy code and write tests first. So that's the end of it. I do, as I mentioned at the start, have a YouTube channel where you get to listen to me randomly about all sorts of things. So there's a couple of things on there which I've coined sort of as an addition to solid principles. So there's test protraction principle, which is really just saying that, tests are more valuable over time than production code, and why that's the case, which again, I think I've touched on in this, and the passive code coverage principle, which is basically build valuable granular tests and the code coverage will come. You don't have to drive it. It is a passive thing. So that's the end of it.
Lovely. Well done. Cheers. I was going to say, if there's any questions, just put them in the chat now. I know there's a guy who was going to come on. Ironically, he works for an internet company. His internet failed it. But his main question that he wanted to know was how to transition a team that doesn't do TDD to doing it, especially when pretty much none of them have any, I guess, experience of it.
I'm in the middle of doing it now. So it's a hard and arduous process, but it's down to that getting buy-in. So it's not cracking a whip and saying do it. So yeah. I kind of started off with kind of almost doing that thing that I'm against, which is the top-down, you must write tests. So I think that's probably the starting point for it, is making sure that they're at least writing tests, but then try to explain, go through what the benefits it can give them, why they want to do it first. And doing bits of coaching on one-to-one, actually showing them, how to do it, going through it, giving them low risk examples is also useful. So get them to write things that aren't necessarily, even giving them exercises that aren't actually writing code for their day job to do. Because there's kind of, with development, as long as you're learning something, you're not wasting time.
Yeah,
it's really bad.
And then the only other one I had was after that is if say you've got like a new requirement that requires a bit of tweaking to an existing test, he says, would you just make a new test altogether, or would you just tweak the one that you've already done?
Well, there's two sides to that. If you write another test that asserts something different, all you're going to end up with is a failing test.
Right, yeah.
So if you write a new test that asserts a new behavior, and that inherently breaks the old behavior, then you're just going to have a broken test. So it would, in most cases, make more sense to change the test. But on the flip side of that, depending on how complex the test is and what you're passing in and so on, it may well be useful to have that test as a reference while you're writing the new one.
Class. Okay, we're recording this, so I'll make sure to show it. Unless there are any other questions anyone has, or if not, we can just call it a day there. I don't think there's been I think we're all good. So I guess just to once again say thanks for putting it all together, and we'll get the videos and everything posted, and we can put all fancy effects on it and whatnot, and make it all shine and everything. But no, cheers to that, Andy. Thank you. We would give a round of applause, but it's a bit awkward on Zoom.